Hi guys, welcome back. This is going to be our last and final section for Chapter 5, Section 5.5. So once you're done with this section, you will be done with Chapter 5. All you have to do is do a review and take your test. And yeah, you'll be good. So just one more section. Hold on, get this assignment done, and you're done with learning anything new for Chapter 5. Okay, so this is special cases. So I've been talking about all week, I've been talking about the 3 different ways to solve a system of equations. You can do graphing, you can use substitution, or you can use elimination. Now it's up to you. I don't care how you get to the answer as long as you get to the right answer. So for this problem, if you chose to use graphing, you could do that. But when you go to graph it, something weird's going to happen, okay? And I don't want to give it away just yet. So what's another method? Would you rather use substitution or elimination? Do you think this problem is better to use substitution or elimination, and why? Think about that for a second. So hopefully you realize that elimination is best because the x's are lined up, the y's are lined up, and the equal signs are lined up. For substitution to be better, you would want it to be x equals or y equals, and we don't have that, okay? We have everything lined up, though, so it's a good elimination problem. So let's do elimination and see what happens. So 3x and 3x, do they eliminate? Close, but we need one of them to be negative, right? What about 2y and 2y? Do they eliminate? Close, but we need one of them to be negative. So let's say I want to make this a negative 3. We learned in section 5.4 that we have to change everything. So this positive 2 is going to become a minus or a negative. And same thing with this positive 2, it becomes a minus. So everything gets the negative symbol. We can't just throw a negative out in front. We have to change all 3. Okay? So now, does the 3x and the negative 3x eliminate? Yeah, it does. What about the 2y and the negative 2y? Does it eliminate? Yeah, it does. Well, that's something new. We haven't ever noticed anything where both letters eliminate. Usually it's just the x's eliminate and you go find y. Or the y's eliminate and you go find x. But now both letters have eliminated. So when stuff eliminates, what number would represent nothing or everything being gone or everything being eliminated? 0. So you have nothing over here. What about over here? 10 minus 2. Well, 10 minus 2 is 8. Are they equal? Is 0 equal to 8? No, obviously this is not true. This is false. Okay? And if you get a false answer, your answer is not false. Your answer is no solution. So once in a while, you'll get a rare case where both the x's and the y's eliminate, and your answer will actually be words. It'll be no solution, or it'll be the next one I'm going to show you in a second. Now, let's say you were graphing. Let's say you graphed the first problem. Okay, I'll do that over here. You would have graphed it, and it would have been a diagonal line, something about like that. Okay, you can go back to the graphing video if you need help with graphing. But you would have got a diagonal line. You would have graphed the second equation, and guess what? You would have gotten another diagonal line, and they would have been the same slope, so they would be parallel. Now, the answer is where they cross. Do these lines ever cross? No. So when you draw 2 lines and they don't cross, that is your answer of no solution. So even if you did another method, you'll still get the same answer. It's just going to look a little different, but your answer would still be no solution. So when you're graphing, don't freak out if 2 lines just don't cross. If you get 2 parallel lines, it means that there's no answer. There is no part where they cross. So since there's no part where they cross, there's no answer and there's no solution. So that's a special case, kind of fun because everything eliminates. It kind of is a quick, easy question. Okay, let's look at the other example. Let's look at what happens when maybe they cross a lot of times. Okay, so that's going to be our next example. Okay, so now for example 2, look at the problem. Do you think it's a good elimination problem? Is everything lined up? No, the x's and the y's are all kind of messed up. So you could graph it. I'll show you what happens if you graph it in a second. Or let's say you want to use substitution. Why would this be a good substitution problem? Look at that second equation. Okay, the second equation is y equals. Anytime you have y equals or x equals, it's a good time to use substitution because you can pull that out and substitute it for something else. So we're going to get rid of the y and replace it with all of that. Okay, so in the first equation where the y is up here, instead of y, we're going to replace it with all that. So I'm going to leave a blank. So I'm going to write my first equation out, but leave a big blank where the y is. So x minus 2y, leave a big blank, equals negative 4. Oops, equals negative 4. Okay, so let's turn a little bit. Okay, so x minus 2y, left a big blank, equals negative 4. All I did was I rewrote the first equation with a big blank here. Now, what's going to go in that blank? Whatever y is, because y was supposed to be there, so I'm going to substitute all this in for y because it's equal to y. So 1/2 x plus 2 goes in that blank. Now what I've done is I've made my problem much easier because instead of having 2 letters to deal with, I only have 1 letter x to deal with, and I can figure out what my x is. Okay, so if you remember, if not, go back to section 5.3 where I taught you how to do substitution. It was section 5.3 part B. Okay, remember though, it's always the same steps. So the first step is distributive property. So we're going to keep this x here. We're going to take this negative 2 and we're going to distribute it to both things. Now remember, it's a negative 2, so you need to multiply everything by negative 2. Negative 2 times 1/2. Okay, if 1/2 scares you, you can always change it to a decimal 0.5. Okay, so negative 2 times 1/2 is just negative 1x. Okay, and negative 2 times positive 2 is negative 4. And then it equals negative 4. Now, at this point, you would combine your like terms. That's the next step. However, what happens when you combine your like terms here? Well, this is a 1x minus 1x. Well, normally it's like 2x plus 3x, and we make it 5x. But 1x, take away 1x, that's 0. That goes away. And we just have negative 4 equals negative 4. Now, is this true or false? But last time it was 0 equals 8. 0 didn't equal 8, so that was false. But is negative 4 equal to negative 4? Yeah, that's true. So whenever you get a true statement, you're not going to write true. That's not the answer. You're going to write infinitely many solutions. Infinitely many solutions. Now that's a lot to write, okay? I'll move it over so you can see. Infinitely many solutions. So we can also write IMS for infinitely many solutions. It means that there's not just one answer, there's infinitely. Just like Buzz Lightyear said, to infinity and beyond. It means keep going on and on and on and on forever. There's not one answer that's right. There's not 2 answers that's right. There's a million different answers that's right. And even then, there's more than a million, okay? It goes on farther than a million answers. It goes farther than a billion answers. It just keeps going on and on and on for infinity. So, what does that mean when you graph? Well, if you graph the first equation, you would get a diagonal line out like that. Okay, go back to section 5.3 part A if you want to go back to the graphing section, and you could learn how to do this one that way. However, you just need to know that it's a line. Okay, then you'd go and graph the second line. Well, when you graph the second line, you're going to get the same exact line. Do the lines cross? Yeah. Do they cross at once? Do they cross twice? Do they cross 3 times, 4 times, 5 times? How many times do they cross? They cross infinitely many times. So it's infinitely many solutions or infinitely many answers. Okay? It's not just one spot where they cross. Okay? It's not like this, what we would expect, where there's just one dot where they cross. Nope. It is the same exact line, meaning all of these are a dot where it crosses. over and over and over, infinitely many times. Okay, so IMS for infinitely many solutions. Okay, if you have questions, let me know. I'm going to put up 2 simple checkpoints, and then we will be done with this section, and you'll be ready for your review and your test. Okay, so here's the checkpoint. This time you might want to pause the video, write it down, try to do it on your own, and then come back and double check your answers. Or if you're kind of still a little lost, go ahead and watch me, and hopefully it makes more sense. So the first one, slide it over. The first one, you're going to look and see, do I want to use elimination or substitution? You could always use graphing on any of these. I just think that graphing is probably your least likely favorite one. So I usually don't use graphing too much, but if you like graphing, go for it. It'll get you the same answer. But I'm guessing you probably are going to go with elimination on this one, since the X's and the Y's are all lined up. Now, do the X's line up? And are they eliminating? Yeah, 5x and negative 5x eliminate. But what happens with the 3y and the negative 3y? It also eliminates. That's a rare case. Usually it's only going to be one of the 2 letters eliminate, and you'll find the answer to the other letter. But when they both eliminate, you have nothing over here. And now over here you have 6 plus 3, which is 9. Is that true? Nope, it's false. And when you have a false answer, your answer is no solution. Okay? If you were to graph it, you would get 2 parallel lines that don't cross. Is there an answer? No, there's no answer because they don't cross, so it's no solution. Okay? It's just a lot quicker to do it with the elimination method versus trying to graph both of these, but it totally would work. Okay, let me move it over to example 2. Okay, look at example 2. You might want to pause the video at this point, try it on your own, and then come back and check your answer. For me, I'm not going to use elimination on this because everything's not lined up. See how the X's and the Y's, it's not XX or YY, but it is Y equals. So all this stuff is equal to Y. So I'm going to use substitution and plug it there for Y. Okay, so I've got negative 6x, negative 6x. I'm not plugging in for x, I'm plugging in for y, because y is what this is equal to. So the y is going to get the blank, equals negative 12. Okay, so now in that blank, you're going to put what y is equal to. So you're substituting for y. So replace the y, and where the y was, you're going to put all of this, 2x minus 4. Now you're going to go back and do the same examples you did for section 5.4 that we did yesterday. It's just going to be something special is going to happen when you do that. So the first step, if you remember from section 5.4, is to use the distributive property. So we've got negative 6x. I haven't changed that at all, but 3 times 2x is positive 6x, and 3 times negative 4 is negative 12, and that equals negative 12. And you can kind of see what's going to happen. Negative 6x and positive 6x. Normally, we would add those together like 2 plus 3 and we'd get 5. But negative 6 and positive 6, what does that make? It makes 0. So all you have is negative 12 equals negative 12. Now this is true. Negative 12 is equal to negative 12. 3 is equal to 3. 0 is equal to 0. That's true. But 0 is not equal to 9. Okay, so that one was false. But this one is true. So when you get a true answer, it's not no solutions. It's infinitely many solutions. And you can write IMS, or if it's a multiple choice question, which it probably will be on the test, it's going to automatically have it wrote out for you. You're just going to have to choose which letter it is. So if it says D, infinitely many solutions, you just bubble in a D. But I'll write it out so you have it. It's infinitely many solutions. Meaning not one right answer, but several infinitely many answers. Okay? And that would be what's on the actual test. It's not going to be abbreviated on the test. But if you're just using like a worksheet or notes and you put IMS down, I definitely know what you mean and I'll give you credit for that. Okay, so that's basically everything that you need to know from section 5.5. To do the worksheet for section 5.5. Let me know if you have any questions. If you have any questions on the whole chapter, let me know. But you are done learning the new information for this chapter. So no new information. It's just going to be a review and then taking the test. Okay, so make sure you're keeping your notes in a notebook or in a folder or some type of organized way, so that you have them all in order. Because the test will also be, everything will be in order of the way you learned it. So it'll be section 5.1, then 5.2, 5.3, 5.4, and then lastly 5.5. There's nothing tricky in the test. It's going to be the same problems. I just might go through and instead of a -6, I might put a -5. Instead of a 3 here, I might change it to a 7. Okay, the problems are still the same. It's just different numbers. But the more you're practicing and doing your worksheets, you should be fine. It should be very, very easy for you. Let me know if you have any questions, and I hope you have a great day.